Welcome to our short tutorial on PCR, where we will present a number of tips and tricks to improve your assay. Although PCR is a very established technique, there are still many things you can do to perfect your results. Our first tip is to recommend that you start by determining the DNA concentration. You can easily measure the DNA concentration of your sample using a photometer. It's easy to understand why a low DNA concentration can cause problems. You just don't get the reaction to work if the template concentration is too low. But a very high DNA concentration can also pose problems. DNA can bind to magnesium, reducing enzyme activity in the process. In addition, you may not have enough matches with both primers binding to the same strand of DNA. And just as important, a lot of DNA can also mean a lot of inhibitors coming from your extraction. This all leads to inferior results. Ideal concentrations of DNA make it easier for your PCR to work effectively. Take the time to measure your samples. Another crucial step in your PCR is setting up the master mix. If you are working with a lot of samples or high-volume assays, we recommend that you prepare the master mix in a large vessel. This helps ensure that the same concentrations are distributed to all PCR tubes, which in turn enhances the reproducibility of your PCR. Preparing your master mix in several vessels will lead to a variation among the assorted master mix setups. These differences can arise from pipetting errors or from other sources. For this reason, you should always use a large tube to hold your master mix. An especially powerful approach for optimizing PCRs is the use of a temperature gradient, which enables you to establish different temperatures across a block. By testing different temperatures, you can determine which annealing or denaturation temperature is the best for your assay. If the temperature in the annealing step is too low, binding of the primers will be unspecific and result in unspecific or no PCR products. Furthermore, a low temperature might have a negative effect on the efficiency of the polymerase. And of course, you don't want that either. If the annealing temperature is too high, insufficient binding of the primers could result. This makes it impossible for the PCR to work. The ideal annealing temperature will give you the best results. Once you know this temperature, you can use it for all your PCR runs. And while you're optimizing your PCR, consider this final tip. Find the ideal magnesium concentration for your PCR. Magnesium catalyzes enzyme activity, so it should be present in the right concentrations at all times. Applying the tips and tricks presented in this video will improve your PCR results. All the information in the video is summarized in this infographic, which can be downloaded at eppendorf.com/stayinformed.